learn a little bit about very simple Python programming on the new Vex IQ version 2. We're not going to go into anything really deep. I'm just going to teach you how to start up a new Python project and essentially find the help that you need, and we're going to write a couple really simple programs to drive the robot around. So what you need to do is you need to go to codeiq.vex.com, or if you're on Chromebook, start up the Vex Code extension. I'll include some links down below for the Vex Code extension and links to the web page here, the web app. So what I'm going to do now that I'm at codeiq.vex.com, I'm going to go to File, and I'm going to do a new text project. New text project. I'm going to discard this. I don't need this stuff. And you'll notice now it's come up with this, and it wants to know what language do we want. Do we want Python or do we want C++? Now, C++ works on their first-gen controller and the second-gen controller. The controller I have is the second-gen controller, and we're going to use Python, and you'll see that it only works on the second-gen controller. All right, so what I'm going to do is I'm going to choose Python. And it starts up a new Python project. Now what I'm going to do is I'm going to connect to my Vex IQ brain. So what I'm going to do is I'm going to plug in a USB cable. I'm going to turn it on. So there we go. It's on. Got the cable. And now I'm going to connect. And up here you're going to see the brain icon, allowing me to connect to the Vex IQ brain. And so I'm going to click the drop down box. And by the way, if you're on Chromebook, you might not have to do that. Chromebooks, I think, it's been my experience, they generally connect automatically. You only have to do this when you're doing the web app via Windows. So I'm going to click on connect, and it's asking me to, or it's basically saying that when you connect, you want to use the Vex Robotics Communications port, not the user port. So I'm going to do that. Vex Robotics Communications port, and click connect. And there we go. Okay, now just like a blocks project, the first thing you're going to want to do is you're going to want to add in all the devices that you have connected to this brain. And the devices are things like the motors and the sensors, etc., that you've got connected. So we're going to come up here to this icon right here, and we're going to click it. And that icon is actually in the shape of the sensor and motor port. So let's go up there and let's click on it. And you'll notice that it's already added the IQ robot brain, second gen. So I'm going to click add a device, and I don't have anything attached to the base bot other than the two motors. Now once again, one mistake that students tend to make is they want to add two motors. They're going to add a motor and then they're going to add a second motor, and you don't need to do that. Okay, don't do that. You're going to want to add a drivetrain, a two-motor drivetrain, and that makes our life a whole lot easier. So let's go ahead and let's select that two-motor drivetrain. And once again, we've got to select our left motor and our right motor port. Now on my base bot, I'm going to have this direction right here be the forward direction. So my robot's going to be a front-wheel drive robot. My motors are going to be in the front. And so my left motor, which is this one right here, I can trace this cable, goes to port number 1. And my right motor comes over here to port number 6. So let's go ahead and let's select port 1 for my left motor and port 6 for my right motor. And we're going to choose brain inertial. Brain inertial. And once again, we don't need to make any changes on the drivetrain settings unless we've changed our wheel size, we've made bigger or smaller wheels, or we've given this robot a gear ratio. We've done none of that. It's a basic base bot. I'm going to click done. Okay, just like in a blocks project, right here, these tabs right here allow you to essentially choose the functions related to each one of these tabs. Drivetrain functions, looks, meaning being able to print to the screen and draw to the screen. Sound, playing sounds, etc. Events, control structures such as your loops, if-then statements, things related to sensors, creating variables, and then creating functions. So it works in many ways very similar to the way the blocks application works. But let's do this, and let's make a program that's going to drive our robot around a little bit. Now you notice this right here gets generated, and all this is basically boilerplate code. Okay, for here you can fill this in. You can put in your project name if you want. We're going to call this basic driving. How about that? The author. And a description. You don't have to do this stuff. This is all comments. Okay. And another thing. Let's come up here to the top, and let's change the title of this project. So I'm going to call it Basic Python Driving. Click Save. All right. So now, and then this right here, this imports the Vex library. That must be in your program and must be at the top. And then it tells us to begin our project code here. So all the code we're going to write is going to go below this line right here. Okay, so what I'm going to do is I'm going to go over here and click on Drivetrain. And if you've done the blocks programming on Vex, these things are labeled almost the same. Drivetrain.drive forward causes our robot to drive forward for a bit, or it turns on the forward motors, causes them to rotate forward. So all we got to do is just click and drag it over to here, and there we go. It's written the code for us. Drivetrain.drive forward. And beside each one of these is a question mark. If you want to know more about that function and what's going on with it, click it, and it tells you. It moves the drivetrain forever. Okay. Once again, we don't have to do anything. Once we get the drive forward in there, it's going to continue to drive forward and execute all the rest of our code. All drivetrain motors run forward or in reverse at the velocity set using the drivetrain's set drive velocity command. So once again, we come over here. Let's see here. Drivetrain set drive velocity. There we go. What I'm going to do is I'm going to drag it right to there, and then whoops, press enter. There we go. So what this does is it sets our velocity. Let's go with 100%. All right, let's continue reading about this. It says how to use, and every single function tells you how to use it. The drive command will run the drivetrain forever until a new drivetrain command is used or the program is stopped. Examples: use the forward argument in all capitals to move the drivetrain forward, and use reverse argument in all capitals to move the drivetrain in reverse. So let's cause it to go forward for 3 seconds and then reverse for 3 seconds. And when it goes reverse, we want to go slowly, maybe 25% power. So we've already got the first part done. This drivetrain.set drive velocity sets it at 100% velocity. And we do drivetrain.drive forward. So it's going to start driving forward. Now, we need to drive for a certain number of seconds. Put a bunch of spaces in here. We need to drive forward for a certain amount of seconds. And if you've done the block programming, you know that that's a control statement. And sure enough, right there, wait 1 second. Let's drag that over to here. And once again, let's look at the documentation. It takes a time. So the first thing we're going to pass to it is the time. And so that is that right there. In this case, it's 1. And then the units. And those units are in seconds. But we can change the units. If you take a look, let me erase this right here. If you take a look, we can change this unit to seconds or milliseconds. We're going to go with seconds. And once again, let's do 3 seconds. So this should cause our robot to set the drive velocity at 100%. Then the next thing it's going to do is it's going to start our drive motors going forward. Then we're going to wait for 3 seconds. Now we want it to go in reverse. And so all we really have to do is do the drivetrain.drive and change this to reverse. And then wait 3 seconds again. So let's do that. Let's come over here to drivetrain. And I could drag this over here, drivetrain.drive forward if I wanted, or I can also realize that it's going to be the same two commands. It's just I'm going to change it to forward. So I'm going to highlight this and do Control and C. That stands for copy. So I'm pressing Control and C at the same time. Then I'm going to put my cursor right there. I'm going to press Control and V. And it pastes. And then I just have to change this to the word reverse. And notice as I type, it's actually trying to complete it for me. And all I have to do is click there and it does that. So now, the way a program works is it's going to start right here at the begin project code. It's going to start executing right here. And it's going to go down executing each line of code. And so the first thing it's going to do is it's going to set the drive velocity to 100%. It's going to start our motors going forward. It's going to wait right here for 3 seconds. So this line right here is going to take 3 seconds to execute. It's going to stay right there. Then it's going to drop down to this line when those 3 seconds have gone by and set our motors in reverse. Then it's going to wait 3 seconds. Our motors will spin in reverse for 3 seconds. And then the program ends, and that will automatically turn off our motors. Oh, you know what we forgot? I said I wanted to, when we went in reverse, to go very slowly in reverse. And so all I have to do is use that drivetrain dot set drive velocity. So that's going to go right here, right after the wait 3 seconds. So before we set our motors in reverse, I want to set that drive velocity. So let's see here. I go drivetrain dot set velocity. So drivetrain set velocity. Let's go really slow. Let's go, I don't know, 25%. So now, just like with block programming, I need to make certain that I come up here and I hit the download button. And it starts to download. Uh-oh, I've got an issue. For some reason. Oh, it's downloading Python system files. If you haven't done Python with it, it has to download the Python system files first. There we go. Okay. Now then, after I've hit download, I've got two ways I can run it. I can run it from here, or I can run it from the controller. I'm just going to run it from here. So we go forward, and then backwards. So let's run that again so you can see. Oh, you know what I didn't do? I needed to turn my drivetrain.stop. There we go. I was wrong. It doesn't actually stop the program, stop the motors when the program ends. So, well, let's do that. Let's put in that drivetrain.stop. And now let's start it up again. And there we go. So that's perfect. All right. You'll notice that on the blocks programming, the very first thing it does is it calibrates the inertial movement system. And it didn't do that here. And if you want it to do that, you've got this calibrate drivetrain function, and you can just put that up right up here at the top. And so now it should calibrate the drivetrain. And for moving forward and backwards, we don't really need it. We only really need it when we're turning precisely. And sure, there we go. Calibrating inertial. We go forward for about 3 seconds, and then we go backwards slower for 3 seconds. That's perfect. All right. If you watched my thing on block programming, we did some interesting stuff with the looks and the sound. We'll do that in just a minute. Let's take a look at driving for a precise distance. So right here, you got the drivetrain drive for, and same thing. I can change these parameters. If I want to know what those parameters are, once again, I can just click the question mark, and it tells us everything that we need to know. It tells us what it does, okay, and how to use it, and what things to change. The distance parameter, okay, so this right here is which direction we want to go forward. This is for how far, 200, and this right here is the units. We want our units to be in millimeters. And it tells us down here that we can actually change these things. So we can change it to reverse, this forward to reverse if we want to go in reverse. And we can change the mm to inches, all in capital letters. And that's important, by the way. It has to be in all capital letters. But I'm going to leave it as millimeters. And so let's do this. Let's do the same program, but let's drive forward. What I'm looking for is the velocity. There we go. Drivetrain set velocity. Once again, let's go 100%. And so this is going to set the velocity at 100%. It's going to drive forward. Let's go 500 millimeters. And then let's cause it to go in reverse. And so let's go, same thing, drivetrain.drive for, and we're going to go in reverse. And once again, as I start to type it, it knows what I'm trying to type, and I can just click there. And let's go in reverse for 500 millimeters. Oh, and once again, let's change the drivetrain velocity. Drivetrain, set drive velocity, there we go. And once again, let's go slowly, let's go 25%. And then once again, we need to drivetrain.stop at the end. So once again, it's going to do almost the same thing. We're going to calibrate the drivetrain. That's going to cause that inertial calibration message to come up. Then we're going to set the drive velocity at 100%. We're going to start driving forward for 500 millimeters. Then we're going to reset our drive velocity to 25%. Then we're going to drive in reverse for 500 millimeters. Then we're going to do drivetrain.stop. And in reality, I don't think we needed it for this one. I'll show you why in just a second. So now we're going to click download. And now let's do start. And we're calibrating inertial. And there we go, 500 millimeters and then 500 millimeters backwards at a slower rate. All right, we don't actually need this right here. And the reason is that this drive for command is actually going to pause right here. Okay, it's not going to go past this drive for command until it's gotten to 500 millimeters. And once it's gotten to 500 millimeters, it will shut the motor off. Unlike the drivetrain.drive commands, that once you start it, that drivetrain starts moving and continues to move until you tell it to do something different. So I've just downloaded it, and let's give it a try. All right, we drive forward, and then we drive backwards, and we stop. There we go. So that's perfect. Now, let's do just a couple other things. Let's take a look at the looks and the sound. So let's add a few looks and sound to our program. So what I'm going to do is, after the calibrate drivetrain, let's have it print out hello VexBot. Okay, and the first thing we're going to want to do, though, is we're going to want to clear the screen. So that's this one right here. And once again, it tells us clear screen. It will not reset the brain screen cursor. So that's important, but it does clear the screen. So after we clear the screen, what we need to do is we need to set the cursor. And here we go. Brain.screen.setCursor1, 1. What that does is it's going to set the cursor at row 1 and column 1. And I bet you anything here, it's going to tell us, it'll tell us how many rows and columns we have based upon the font that we have selected. All right. So we're going to set that to the upper left screen, upper left of the screen. And now let's print hello VexBot. Now let's draw a circle on the screen. So if we come down to here, we can see right here, brain dot screen dot draw circle. But before we do that, let me press Control Z. Let's set our colors. Okay, let's set the pen color, the pen it's going to draw in, and the fill color. And we're going to change it to purple. So if we take a look here, it shows us all the different colors we can use, and there's color.purple right there. So what I have to do is I have to change this color.red to color.purple. And once again, it's important. It is important that it is in all capitals. Okay. So now we can do the draw circle. It's going to draw in purple. So brain.screen.draw circle. So let's take a look. So the first parameter is the X, and the second parameter is the Y. And so the X is the X coordinate of the circle center, and the Y is, of course, the Y coordinate of the circle center. And the third number is the radius in pixels. All right, so let's do it at, you'll see that we're 159. Let me show you this. Let me highlight it. The screen is 159 pixels across, okay, going in the X direction. Okay, that's the X direction. And it's 107 pixels in the Y direction. And this up here, the upper left, is 0, 0. So let's put our circle at about the middle. So 150 divided by 2 is approximately 80. And 107 divided by 2 is approximately, we'll call it 53. So we want our X coordinate to be 80 and our Y coordinate to be 53. So let's do 80 by 53. 80 comma 53, and the radius is going to be 10 pixels. All right, so let me get rid of all this blank space. So now we basically added this, and once again, it is going to start here. Okay, I'll put a big S for the start, and it's going to execute line 42, then line 43, then line 44, going line by line down through our Python code. So the first thing it's going to do is it's going to calibrate the drivetrain. That's where we get the little message on the screen. And once again, we only really need to do that if we're doing turning. Then we're going to clear the screen on the brain. That's brain.screen.clear screen. Then what we're going to do is we're going to set the cursor to row 1 and column 1. So that's going to be the upper left once again. And then we're going to print hello VexBot. Then what we're going to do is it's going to come down. We're going to set our pen color and our fill color to purple. Then we're going to draw a circle at approximately the middle of the screen. Then we're going to set our drive velocity. We're going to drive forward for 500 millimeters. Then we're going to slow down and drive in reverse for 500 millimeters. And then the program stops. One other thing I want to do is play, well, I'll add that in a minute. I do want to put in, after we draw everything, after the draw circle, so after on my screen, line 48, let's put in a little pause on line 49. So we're going to come over here to Control. We're going to do this wait. Let's wait for 3 seconds. And then start. So here we go. Download. And let's start. Perfect. And now we start, and now we go backwards. So I don't know if you can see this. Let me turn this light off. I don't know if this will make it better or worse for you. I know it's having difficulty focusing. There we go. All right. It printed hello world, and then it put our purple dot there. Then it waited 3 seconds. That was that pause. Then it drove forward, then it drove backwards. Let's add a bit of a sound into it real quick, and then we'll be done. So if I click on the sound tab, I have a few sounds that I can do, and I want to do a sound just before that 3-second pause. So that's on line 49. So I'm going to put my cursor at the end of line 48 and press enter. Now once again, let's drag this brain.play sound, and it's set to the siren sound. We can actually do a bunch of different sounds. I think we might do the siren. Yeah, let's do the siren. And then at the very end, when it's done, let's do another sound. Let's do the ta-da sound. And so we can come over here, drag that down to there, and it's sound type dot ta-da. And what I can do, I can actually cut it and go Control C, highlight it, and then here, do Control V, and I think we're ready to go. So let's click download, and let's do start. Calibrating inertial. That was the siren sound. Waits 3 seconds, drives forward and then backwards, and then ta-da, perfect. What I encourage you to do now, the best way to get good at programming is just experiment. Get in there and start doing things. Don't be afraid of making a mistake. Don't be afraid. You're not going to break the Vex brain by running these Python programs. Okay? The best thing to do is just get in there and start experimenting. You don't know how to do a lot if this is all you know how to do, but you can do quite a bit with all these drive commands. And I encourage you to get in there and maybe build a little obstacle course or something and try to navigate through that obstacle course using these, and maybe once it gets around each obstacle you play a sound or something like that. One other thing I want to show you is comments. All these hashtags here, it turns green, those are comments. They don't actually do anything. Okay, they're for you, they're for the programmer. And so you might put in a comment here with the hashtag that says set up and do screen things. And then maybe over here you do hashtag start driving portion. One of the things I noticed, my students, when they're doing contests, these programs can turn into hundreds, even thousands of lines long. And unfortunately, due to the nature of the type of coding that we do in robotics, you get a lot of repetitive code, or code that looks a lot like go forward, go backwards, turn left, turn right. And it can be very difficult. Let's say your robot's a minute and a half into its autonomous routine, and you notice a left turn that needs to be adjusted. And you're like, oh, that left turn a minute and a half in needs to be a few more degrees larger. But then going through your code, trying to find where that left turn is, and you may turn left, 12.5 times in your program or more, and finding out which exact left turn that is to adjust could be difficult. And these comments, or making comments about what the robot's doing, make it much, much easier. So get in there, just start programming, just start writing stuff. Like I said, set up a little obstacle course, make the robot navigate the obstacle course, maybe play a sound after it gets through each obstacle, or print stuff on the screen, etc. If you got any questions, just leave them down below. Thanks a lot. Bye-bye.